Okay, we'll be looking at substitution methods for second order differential equations. For this, I'm just going to say we have solved differential equations of the form AD squared y on dx squared plus b dy dx plus cy equals some function of x. But we may have differential equations. In this case, a, b, and the c are constants. But we may have differential equations in which these coefficients here are not constants. For example, you may have a differential equation like x d squared y dx squared plus xy dy dx plus 2x minus y equals some f of function of x. We don't have a method for solving this one yet. So substitution method. Substitution tries to transform this differential equation into this form. If we can transform it into this form, then we can solve it. So substitution is not very new. It works exactly the same as what we did when we were doing substitution for differentiation. So we have this, we start with first order differential equation just so that it looks very easy. We have dy dx equal x plus y over x. We can write this as dy dx equal 1 plus y over x, correct? And then now we will use the substitution. Let u be equal to y over x. Y over x. And then we will have to look for dy dx in terms of u. This means that y is equal to ux. And so now we look for dy dx. Dy dx, we will use the product rule here. Since u is some function of x, u depends on x, so we will use the product rule here. We leave u first, we differentiate x, and then we leave x, we differentiate u, du dx. So dy dx becomes u plus x du dx. So this equation becomes let me write it. So our differential equation becomes dy dx is x plus u plus x du dx. So you have u plus x du dx. Let me write this as u, not like y. So this should be equal to 1 plus u. And now you can see that the u cancels out. And we'll get x du dx is equal to 1. We can easily solve this now using a known method. So du should be equal to 1 over x dx. We can separate variables here. That gives us u should be integral of 1 over x dx plus c. That is a method we know. So that will be natural log of x plus c. Let me put absolute value here. And then we have to go back. U is y over x. So we have to give the function as y equal f of x, not u equal f of x. So this means y over x should be natural log of x plus c, giving us y equal x log x plus cx. We can show that this equation, we can show that this function satisfies this differential equation by differentiating and then showing that it is like that. But no need for me to do that now. Okay. Okay. How about second order differential equations? Once more, this section may be one of the easiest on differential equations. Huh? Why? Because in examinations, you will usually, in most cases, you will be given the substitution to use. Okay? Questions will always ask that, show that by using the substitution u equal yx, this differential equation can be transformed into this other form. And then they will say, hence, solve the differential equation. So the first part will always tell you that you should use this substitution to change this differential, to show that you can change this differential equation into another form. You'll be given the form. So you have to do that carefully since it says show that. So in this case, we are going to use this substitution to change this differential into the form a dy d squared something, d squared u over dx squared plus b du dx plus cu equals some function of x. We are going to use this substitution to change that to that form. So we know our u is yx. So we have to find dy dx, and we also have to find d squared y dx squared. Before I move into that, I have to tell you guys something. You should never, even if this equation was given as y equal u over x, you should never try to differentiate it as a chain, okay, or as a quotient. Never you try to say, to put it in this form before you differentiate. Put it in the simplest form. In the simplest form, and then you differentiate all through. We have dy dx here. We also have d squared y dx squared. So you must also understand that you will have du dx, and you will also have d squared u over dx squared. So just put the equation in the simplest form, then differentiate it all through. So we have u, where is it? U equal yx. So we will differentiate all through. Du dx, we use the product rule. So we will get y, you leave y, you differentiate x, plus you leave x, you differentiate y, x dy dx. I will then say, therefore, x dy dx is equal to du dx minus y. This is important because I know when I will expand this, I will have x dy dx. So I can leave it in this form. I don't need to find dy dx only. It will make it more complicated. Second, I need to find x d squared y dx squared. So I'll come back to this equation. I'll differentiate it all through again. So I'll have d squared u dx squared. When I differentiate this, I'll have dy dx plus, for this second part, I have to use the chain rule again, or product rule again. I will first leave dy dx, I differentiate x. So dy dx. And then I leave x, I differentiate dy dx, so I get x d squared y dx squared. This means that x d squared y dx squared is equal to d squared u dx squared minus 2 dy dx. This is another function I need because I have x d squared y dx squared here. So I will come back to the original equation, our differential equation. I will expand it. I don't want to have these brackets here. I'll expand it all through. So I'll have x d squared y over dx squared plus 2 dy dx plus 2 dy dx minus 2 x dy dx minus 2y minus 3xy is equal to e raised to the power 2x. Now I will come here and substitute all the terms. X dy dx is x dy dx is d squared u over dx squared minus 2 dy dx I'll leave this as it is. I'll leave this as this. So plus 2 dy dx minus 2. X dy dx is du dx minus y. So minus 2 du dx plus 2y minus 2y minus this term xy. Xy is u, so minus 3u equal e raised to the power 2x. And so this will cancel with that. And that will cancel with that to give us d squared u dx squared minus 2 du dx minus 3u equal e raised to the power 2x. Okay, this is the first part of the problem. They will ask you to show that this differential equation can be, by using this substitution, this differential equation can be written like this. So you will show it like that. Show it carefully. Remember, you always have to be very careful in everything you are doing. Otherwise, you will make a mistake somewhere. I have solved problems like this and I've made so many mistakes. Since, I always make mistakes with positives and negatives, ones and twos. And then the second part of the problem will say, hence, solve the differential equation. So from here, we can write our auxiliary equation. Our auxiliary equation is m squared minus 2m minus 3 equals 0. And then we look for m. What is m here? Can we factorize this? Negative 3 is negative 2 times 1. So we'll have m plus 1 negative 3 times m minus 3 equals 0. That gives us m equal negative 1 or m equal 3. So our complementary function, so y complementary is a e raised to the power negative x plus b e raised to the power 3x. And then we have to look for a particular integral. Sorry. This is not y complementary. This should be u complementary. U complementary is that since our differential equation is in terms of u, and then we look for our particular integral. So since this is e raised to the power 2x, we will make u equal c e raised to the power 2x. Then du dx will be 2c e raised to the power 2x, and d squared u on dx squared will be 4c e raised to the power 2x. I know you can all solve this one. I'm just doing this for fun. I'm just doing it for fun. I'm not doing it because I want to show you how to do that. And then we substitute here, we get 4c e raised to the power 2x minus 2 times 2c e raised to the power 2x minus 3 times c e raised to the power 2x should be e raised to the power 2x. And so this cancels out with that. So we can cancel out the e raised to the power 2x. This means that c is equal to -1/3. So our y, our u, so our u particular is -1/3 e raised to the power 2x. Therefore, our general solution, u general, is a e raised to the power -x plus b e raised to the power 3x minus 1/3 e raised to the power 2x. Should we end here? No. We have to transform u back to y. U is yx. So we have to come back here and write it as y times x is equal to a e raised to the power -x plus b e raised to the power 3x minus 1/3 e raised to the power 2x. This means y, the general solution for y should be a over x e raised to the power -x plus b over x e raised to the power 3x minus 1/3x e raised to the power 2x. Okay, you get the idea. So that is how you do substitution in differential equations. You have to go, this is what I see. None of you guys, you completed lesson 6 yesterday. Even though some of you told me you watched the videos, but you didn't click on complete. When you watch the videos, you must when you finish a lesson, you must click on complete, okay? Otherwise, you cannot advance to the next lesson. If you click on complete, you will advance to the next lesson automatically. So, you will watch these videos on lesson 7 today. They also solve some past paper examples. There are only 2 videos. You must watch them because the substitutions they use here are not exactly the same as the kind of substitutions I solved. They are not the same kind of substitutions you also have in the book. Okay? And then when you finish, you do complete the assignment. Okay? Okay.